Okay,
All right.
so chapters 1
It's
to
only
4.
the three of us.
Well, we have other two people saying interested in the event, but I don't know if they're gonna join.
Right.
Uh, this is cool though. This a fridge, a typical C user. That's cool. So chapter 1 is basically saying this is not for people that get enraged by debugging and stuff like that. So be aware of that. We are fine. Everybody spent a lot of time through that. So
This is for hacker wannabes, which we are, which is very
yes,
convenient.
yes. It is saying specifically that term, which is also very cool. Uh, so basically C because well everybody should know C nowadays anyway.
Yeah.
Um, it is saying that it is a difficult language, which is interesting because a lot of people don't say that.
Uh,
A lot of people don't say that.
Yeah.
I
I
believe a lot
don't.
of people still consider this to be difficult, to be a difficult language.
Well,
I
I
consider
usually hear that C is a simple language.
simple is not
Yeah.
necessarily the same as easy, though.
Yes.
Yeah, so it's a simple but difficult, but
Com-
people don't say the latter part. They only say that it is simple.
yeah, but yeah, maybe this is just my rant here, but computers are difficult, right?
Yeah,
It's a
that's
hard
fair.
model to grasp and to be productive on.
That's
So
very
this is
fair.
not a problem of C.
Yeah,
Next up, go on, Michael.
it's a
Go.
consequence of C being a very low level language. Like it really exposes you to the computer and how it works. Because computers are difficult, C is difficult because you are ultimately working with a computer. So it's a
Yeah, but
relative, yeah, but it's a relatively
this is
simple language, despite that.
yeah, but yeah. But as I used to say, people consider Python to be an easy language. But I
No,
can't agree because it's easy to run something and see something on the screen, but it's
no,
99% of the time it's broken.
no.
Yeah, so
Python is complex
the
and it's also
easiness,
difficult, but it's
It's
difficult in
easy
a
to
different way.
write.
Yeah.
the easiness
It's easy to
of
write the wrong code.
the easiness of writing doesn't mean correctness, right? So that makes sense.
Yes.
My
Anyway, so now we have
Python
why
is
build Lisp,
difficult.
which basically means it. I think the argument is basically because it's also simple, and
It is.
and
It
it's
is.
also and he says the thing that Commander will be pissed, which is that
Which is
Lisp is gonna be is based on lists as the main mental model of the main foundation of in terms of abstraction.
Actually, it's
not just
technically speaking, it's not necessarily the basic foundation for abstraction. It's the basic foundation for how you represent code, which is a slightly different concept.
I think I meant to say that, but anyway. Teach use function programming, novel ways of doing computation. That's very okay. It also
Nice
says that
Python.
I'm not gonna be bothered if you say that my Lisp isn't the Lisp. That's fine. You can have yours. And he
oh
also
yeah, and he's quite opinionated on the list of the he implements on the book.
yeah, I imagine. And he also says for us to not just try to make it run, which fortunately Edu made this repo, which already has a bunch of code. Of course, I can't run it because I'm using Nix. That's like minor details.
No, you
Uh,
just need a GCC compiler. You just open a Nix shell with the GCC and
Yeah. No,
you
no.
will be good.
I was kind of like sort of joking. I understand. I can
Ah, okay.
I can have an
even
Excel
if
with GCC.
That is not even make files there.
and actually, even if you didn't understand, that's fine because the next chapter is exactly about that. So we're okay.
Wait, about what? About the how to run it?
Yeah, that's in the compiler,
Yeah.
hello world, compilation. It
No.
basically
That part,
teaches
yeah,
you.
that.
Yeah.
That part is fine. The problem is the rest of it. You understand. You're using something similar to Nix. You kind of understand the headache anyway. Anyway,
I'm I'm
What's
using Git
something similar to Nix?
this.
GNU Git.
GNU Geeks? What the hell is that?
It's basically Nix,
Yeah,
except they didn't like the language, so they rewrote it in Scheme.
yeah,
Ah, Lemos told me about it.
yeah. So he's the guy that uses it.
Holy Lord.
Yeah, yeah, yeah. So now you see how Nutella
At
you are
least,
with your macOS, right? Now you understand.
oh, I love being Nutella.
Okay,
And
so
now I'm trying to grasp how to compile something with using these Docker images, and it's like a hell.
yeah, 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 I understand. But yeah, that's a different learning curve anyway. So, and again, be aware that I told you this already. You can use Nix to do the same things you would use Docker, but Docker doesn't have the same approach to being reproducible anyway.
And you can use Geeks to do the same things you do in Nix, except you have a better language to do it in.
Yeah, I agree that the language seems to be better, although I don't have a very deep Nix language knowledge anyway. Okay, so I'm not gonna go through all this because this is basically if you don't know C, everybody here knows C, so that's fine.
Yeah.
Uh, so we also
So this
have,
is the basics,
yeah, this
the
is also
C
the
basics,
basics.
declaring
He
variables.
makes a question. Which other basic types do we have in C? I don't remember much more than this. So am I wrong? Do we have much more than this?
Uh, Depends on
Well,
what you consider to be basic types because you have those word you int
No, but
something
that's a
int.
library.
No, more or less because it's in the standard library,
Yeah,
and
but you
so
have to
it's
import
considered
it.
to be basic types.
technically you have structs and enums, I guess.
No, no, no. But this is
Yeah,
not what he's calling basic built-in
basic.
built-in types.
Built-in types.
Oh, that's
Yeah.
fair. That's fair. Yeah,
Uh,
that's
Yeah, so I believe this
point,
is it.
char, int, long. Yeah, that's it actually. I think.
okay, then function declarations, then struct,
Mm-hmm.
and I also think this would include the enums as like um, custom types.
Man, I really don't like the fact that the name of the struct comes at the end. That's weird.
No, but there's an
Yeah.
explanation for that. There is an explanation for that.
Yeah,
So
in this case, it's using in the end because of the type def.
exactly. So if you want to be able to use a different name as an alias to all of that, that's why you do at the end the name.
I see.
Which I didn't know. I actually thought it would be something different, but I checked the reference just to see, and yes, it is because of that. Then we have pointers, which is he basically skips it because yes. Then
Oh yeah,
strings.
I didn't remember that he just skipped the thing.
Yeah, he said he's using, and then there are difficult part. This is the difficult part of C. We won't make use them for a while, so, but we will go to them later. That's what he says.
Okay.
So strings, which are basically char stars, that's fine. Then we have what makes the language string complete, aside from assignments. Then we have the questions, and this is where he says what built-in types are older than the ones listed. That's why I asked. Uh,
Mm,
and that's pretty much it. There's nothing like much more important than that. So in the an interactive prompt. So this is chapter 4.
yeah.
Okay, this is
I
very
think
cool. So the
technically,
first question that I have, why did he choose to use puts instead of printf all the way? Does anybody have a guess? I think
well,
it's because um, printf is kind of like generic in a way because you can have an arbitrary number of things going on there.
actually,
And
printf is technically a compiler built in. It's magic. It's literally magic.
I don't
It's
think it's a
magic.
compiler built-in. It's inside this.
Hmm?
No, it is a compiler. It has to be because like it has to check the that the format string is correct, right? And the number of the arguments. Like there's
I
not
No,
really
see.
but
some.
it's a lot of code actually in the standard library to do that. Actually, you can roll up your own printf.
I don't. I really don't think it's a compiler thing, Marinho.
No,
No,
it's not a compiler thing.
I remember actually watching a talk by the creator of Zig, and he mentioned specifically printf. Like he called it out specifically as something that's usually a compiler built in because it's difficult to impossible to express in pure C, like if you don't already have it.
I think you need to use the trick code for printf. I think you kind of need to use the trick. Yes, you need to use this.
Hmm. Which is
Uh,
kind of magic.
yeah, that's magic.
But then no, but then
Kind of
it
magic.
comes down to VF printf, which is literally magic, basically.
Here's a link to all the formatting magic happens
Amazing.
there. This is why we're gonna know is it a macro or not? vprintf.
IO
Not
VF
even there.
printf
Oh,
kernel.
it is in here.
IOV. Oh my shit.
IO vprintf internal. Okay.
What the hell?
Okay, so there's only 4 mentions. So
LDBL. What is
we're
this?
not gonna know. We're not gonna know. I think.
Semilhas.
It's
Yeah, but
compiler magic, as I
it's
said.
coming from some
It, yeah,
imports
but now
probably.
I think I agree with Marinho. It really seems to be compiler because there's only compiler. What's the name of this? Uh, this is what the preprocessor takes a look, right? When you use this if def here and this else and this if here, this is
Yeah.
when the preprocessor is gonna do stuff. So this is basically compile time implementation. So I believe Marinho now.
And like the creator of Zig, I think his name is Andrew Kelly, if I remember correctly. I'm not that great with names, but it specifically calls out printf because it is in fact possible to write printf in user space in Zig, but not in in C, and actually Rust as well. It's built into the compiler too.
Yeah, well, I don't know if it's possible or not. I just understand that it may be just a compiler thing because of the magic. That's okay. Anyway, so what we are doing here in this piece of code is basically making an infinite loop that will basically we are starting to implement a REPL, right? So you're gonna have like a message in the beginning of
Guys,
it.
can you? Oh no, sorry.
Go.
No. I was asking a stupid question,
Okay.
but I was because I'm reading the documentation for notes here, and I was never mind.
Okay. Then he's using puts to print some initial information. Then he's uh, printing this into the std out because fputs allows you to actually put a target of which output stream device you're going to use. Then he's using fgets with a maximum of 2048 characters. And then he's just printing out loud what the heck you said it. And then he explains all of that, which again, I'm not going to go through all of this because everybody here knows C. Here's an example of the thing actually running. Uh,
Yeah,
important to notice. Important to notice. This f puts here. This is the cursor will be only it will be after this, right? So you're gonna
Yeah,
type
after
something
space.
there, and then when you press the enter, that's when the std in is gonna grab. So this the f gets sorry in the std in. This is gonna grab until the new line, and then we're gonna
Yeah,
print that. We're gonna print that. I don't actually remember.
exactly. You can actually run this because just go
Oh
there.
no, I actually remember. Yes, the fgets puts the new line by itself. That's why you don't need to put the new line in the printf. So is
What?
there? Yeah. So this is a very tricky thing. So the question is why after you press an enter, the printf is putting this and then a new line.
Because there's a new line in the line that you entered. The
Exactly.
thing.
Yeah, but my
But
initial intuition
it.
was this is missing a new line in the printf. But that's wrong because the
Ah, okay.
the fgets is already grabbing the new line for you.
Yeah, yeah. It includes the new line
Cool.
that you
So do
gave
you
it,
have a file with that?
which is prompt.c, I believe.
Prompt.
Yeah.
Oh, you get. Oh no, it's only this. Oh, this is the end of the chapter. We're gonna get there. So let's actually finish.
Yeah, it's everything's already
So
from there.
compilation, example, and then we have the problem of the history, right? So how you use the arrows. So
Not only history, but arrows in general.
uh, I ask myself if we actually need to use an external library. Why couldn't we just use RL
What is RL wrap?
It's uh, it's a it's a program that receives your program and allows you to have all the arrow functionalities automatically.
Wow, interesting.
So
Yeah, it's basically the readline library that he's using in the book.
Yeah,
yes, yes,
Technically
yeah,
he's
yeah.
using editline, but readline is a drop-in replacement. It's literally readline wrap. That's how you read the command name.
yes. So when you
So
have a
you
program that has garbage interactive environments, for instance, the first one that comes into my mind, SBCL, right? It's garbage. So you want to have history and
SBC.
the arrows and stuff like that, you can wrap SBCL with this, and then you get I believe you get normal functionality of the arrows that you would expect
How, how
of
do
a
you wrap
proper.
something
You
on
just
this?
pass it here. So let me see if
Just
they have an
pass it,
yeah, you
huh?
just put
yeah
LR wrap and then your program as you would run your program.
yeah basically RL wrap it takes over the IO to the terminal, right?
Yes.
And
Mm-hmm.
then it passes it along to the program, but as it does that, it passes it through the normal read
Oh,
line
here's an example. So I think you would
history
normally
handling.
run netcat like this, but instead of doing that, you just put RL wrap in the beginning. And everything is going to work as
Nice.
you expect. But but because of the they are like manip- grabbing the output or to the screen before the actual program, they can change the how the arrows is going to work and stuff like that.
Yeah, probably he changed the keyboard codes that
Yes,
it's sent to
yes,
the stuff, right?
yeah. So, but let's go through
Interesting.
through this anyway. So he wants to
Yeah,
have
but he
history,
uses readline.
and he uses this only for Linux and Mac because for some random reason the Windows works.
The Windows what?
In Windows, you don't have to do any of this.
Oh yeah,
It,
Windows is not broken.
it's very weird. It's one of the few cases in history apparently that this is the case.
Uh,
So basically, he's reading the line once again, but now the read line is not grabbing the new line for you, which means that you need to add a new line in the printf now. Hmm?
Hmm.
And there's also
Might
the
have the
thing,
case.
about the memory leaking. So he is basically this is doing an a malloc of this piece of memory, and now he's just freeing it after. So that's okay. And then he's gonna say that's not gonna work because you need to install the dependencies. Welcome to the dependency hell. That's fine. And then he's gonna use the preprocessor directives. I don't remember the name of these things. Preprocessor something.
C C preprocessor. Macros. They are called macros.
In order to conditionally change the definitions of this read line and add history functions depending on the OS that you are. So if you are in Windows, you're gonna include this block of code, and if you aren't, you just gonna include this.
this is basically the worst way possible to do metaprogramming, and it's what C does. It's amazing.
Uh, I think you're right in terms of like the convenience in the ratio between convenience and power, but you have all the power. It's just not convenient. I think you can
Yeah,
do everything with this.
I mean, technically, if you run the C preprocessor, like just a preprocessor, and you keep running it again and again on the same file, it's technically Turing complete.
Oh well, I
Really?
didn't know that.
It is.
Cool.
Oh shit.
He also
Yeah, because
implements
you can create new macros and new macros ad eternum, right?
yes.
Yeah.
Makes sense.
He creates a very his own implementation using fputs and fgets of the read line for Windows. Oh, okay. So apparently Windows only does the history part by itself. apparently. You don't need to the read line. He needs to implement it. That makes sense. And that's pretty much it for chapter 4. So anything that you guys want to comment on about this? Because for me, it's like, yeah, that's fine.
Yeah, no, that's fine. Just
It's
making
fine.
It's fine, right?
something that reads a prompt.
Yeah. So then we go to the chapter that I didn't read, but I don't know if you guys want to continue, we can continue.
No, go on.
I
Uh,
think I did start reading chapter 5. I don't remember if I finished it. But yes, it basically
It,
said, you know what, parsing is difficult in C. Let's just use a library. And actually,
yeah,
that's kind of fair because he wrote the library himself, apparently. So,
yeah,
yes, yeah.
he's saying that I have written. Yeah, but that's the thing. I'm very curious to see the source code of this because how the heck you gonna represent functions, man? Like everything is a void star in C, basically. Is that how he did it?
yeah, if you have a void star and it happens to be a pointer to a function, you can just call it. It works.
Yeah, but how that's gonna look like? Like I made parser
Just
combinators.
read the code. Just read the code
Oh,
there.
so
It's
you do have the library
in
here.
this page.
But the library doesn't, I don't think the library uses void star for everything. It has proper types.
Yeah, no,
Proper
it's kind of
types.
okay.
It's kind of okay. Okay, so let's go through an example. So input new string. Uh, so what is it doing here? So is this the combinator MPC input T?
It's no, this is a struct that's above.
Yeah,
Yes,
no, I
this is
understand that,
struct.
but what does this mean? Well, like what's the purpose of it?
This is something that keeps tracks of everything that's happening
Int type
on the
file
parser.
name. Okay, so this is a function that does what exactly?
I don't remember.
I think this is only loading. I think this is only loading the information of this
Actually,
file into this struct.
it's easier if you go to the book and see it in action, being used in action, because you will understand then the source code better.
Build and eject a parser adjective to recognize descriptions. Oh,
For example, yeah. So for example, you have an or four things, and each one of the things are trying to parse exactly
oh,
wow,
that's how
many,
he does
so
it
and
then.
such.
So you have to know beforehand how many parsers you're gonna use, and probably he's
Yeah,
doing
of
like a
course.
for loop. No, that's not of course, because in Lisp and in Haskell you don't need to do that.
It's simply arity, except you don't have arity inference, which sucks.
Mm-hmm.
Anyway, so you provide. So probably he's doing like a for loop with this number there, and he's following this order. So wait, but is he using? Okay, so we have four things here
He's
and four things
using,
here.
yeah, he's using the same thing as printf, the
Oh, so the
three
dot
dots.
dot dot. Okay, so okay,
Yeah,
so he's using
because
that.
then you can have as many arguments as you want.
Yeah, but is he checking if you have like six things here in number five? Is he
I
I
checking
don't
that?
don't think
know.
so.
Now you can go to the source code and see how it works.
I'm pretty sure
The
that
MPC
varargs in
or
C, I'm pretty sure that varargs in C, you just get a pointer, which is a pointer to an array, obviously,
Oh,
but pointers to arrays don't know their own length, so you have to pass that separately, which is why you have to pass in the number of arguments as
yeah, yeah,
well.
yeah, but that's not the question. The question is he checking?
Ah,
Reading
probably.
the code doesn't seem that he's
yeah,
checking.
you have n
Yeah,
that he
n is
uses
the
Uh,
for
argument.
malloc. You see,
no, he's using for malloc, but that doesn't.
It's in the for loop. It's in the for loop.
No, it is in the for loop as well, but yeah, he's not checking. Which means that if I put five but put seven here, he's only gonna use the first five, but he's not
Yes.
gonna
yeah,
complain about adding more. That
yeah.
And
But
of
if
course,
you
if you put
if you say there are five and give only three,
yeah,
that
then he's
might
gonna
break the
check.
thing,
Then it's
right?
gonna break. Then it's gonna break.
it's gonna break.
Yeah, that's okay. That's okay. But he's not checking the other way around. That's okay. Okay, so well, everybody here also knows parser combinators. Uh, but well, if this
I
is going
hope
to
so.
YouTube and somebody doesn't know, I feel kind of bad. So I may add in the description some references to parser combinator things. So it's basically a way that you can parse instead of doing like token by token. Because in C, I think people usually do token by token, right?
Yeah.
In C, it's also
I believe he's also doing token by token thing because if I remember it well, he has a lexer before the parser here.
No, but if you have the Lexer, you don't have to. Well, you can. We have tokens, but you can have more like organized tokens. So, for instance, if you have something between spaces, that's a single token
Mm-hmm.
instead of only a character,
Mm-hmm.
right?
Mm-hmm.
But this layer of abstraction that he made here, of the parser combinator library that he made, this basically allows him to not have to go to the level of tokens if he wants to.
Mm-hmm.
Of course, you can combine them, so you can have like the stream of the string stream, then you apply the lexer to transform that to a list of tokens, and then in order to form the tree, in order to actually put the syntax on top of the tokens, then you can use something else to do that.
Am I
Um,
the only one here who likes to go for scannerless parsing? Like, don't bother with
yes, you are the only
tokenizing as a
one here. So
separate
let me
step.
explain to my Edu what you said means. So instead of having the stream of string stream, then tokens, then the AST, and then you pick the AST and you throw that to the compiler. Marinho's language, which is still in the conceptualizing phase, he's gonna skip all of that, and he's gonna pick the stream and he parse it and immediately already evaluate it. So he doesn't
Before
have.
continuing to parse,
As you
Yes,
parse it, you
yes,
evaluate it when you have enough
yes, yes.
information about what's
yes,
happening.
Yes.
yeah.
So that
Why?
means that
Why would
there
you
is a
do this?
continuous transformation. So he's trying like
Uh-huh.
grabbing
It's
information
like a
from
stream of
exactly,
stream
exactly,
execution.
exactly.
The idea is I wanted to have some nice Lisp-like metaprogramming, but I don't like macros because they are second class. You can't like they have to appear under their own names. You can't treat them as values because they aren't actually values at runtime, right?
Mhm.
Uh, but if you do it this way, then you can take any ordinary function and you put it in a context where it will be called by the reader, and it essentially becomes a macro because it's going to be called at read time. So you
Yeah, it's
have
a
mac
different.
you
It is a
basically
different sort of
yeah
mental model to see like the entire pipeline because he doesn't have effectively a pipeline. He has only one phase, which is everything combined. And but there's a good thing about that, like aside from what he just said, because I don't fully comprehend still what he said. But there's another thing. You don't have to be aware. You don't have to be like afraid of context dependent grammars because it doesn't matter. The problem,
Doesn't matter.
yeah, because when you have a known free context free grammar, the problem is after the parsing phase is done, you may have a program that doesn't parse as you would like to parse because there's some ambiguity in your grammar.
Hmm.
And a lot of the times you can remove the ambiguity by adding context to the parser. So the parser is smart. He's not only following a bunch of rules. So the parser knows context stuff. And when he knows context stuff, he can make smarter decisions
yeah
when
I
when parsing.
personally yeah when I write parsers and I'm not writing them out by hand, I like to use peg parsing actually. Parser expression grammars, which they're pretty similar to context-free grammars, except the choice operator is ordered. So instead of having no order, like you can put A or B, or you can put B or A, and it doesn't matter. If you put A or B, if you try to parse A first, if that succeeds, it commits to the choice, and it will never backtrack to try B again.
Yeah, that's what
So,
Haskell does as well with the mega
yeah.
parsec or parsec things.
The other of the alternatives matter. So this way it's an ambiguous grammar because like its source of ambiguity, which would be the fact that the choice has no order, it's just gone from the formalism.
I don't understand. As far as I can tell, in the alternate, if you do B alternative A or A alternative B in megaparsec, it doesn't matter.
It matters, actually. It matters.
No, in parsec matters. In megaparsec, I'm saying it doesn't matter.
Oh, yeah.
Because in
Megaparsec,
megaparsec,
yeah.
it does
Right.
backtracking when it fails.
No, but even it bags do backtracking as well, but the backtracking is restricted. Like if A fails, like if you have A or B and you manage to parse an A, it commits. It no longer backtracks. But if A fails, then it backtracks and tries B.
Yeah, would be the same process with B.
What's the
What's the
difference?
difference?
The difference is that if you parse an A and you succeed, it and then it fails in a subsequent thing that's outside of the choice, it won't go back to the choice and try the B again because it's
That's
already
also the case
committed
in
to A.
Haskell. That's the case in Haskell, what you just
Yeah.
said. If you have two things and one of them is an alternative between two things parsing, if it fails on the latter, it doesn't matter. It is already committed to the previously parsed thing.
Yeah.
But this is the
In your
important difference. Go, Eiju.
but in your case, what would happen
He's asking you, Marinho.
Um,
because of this stream thing?
Oh, he's
well, if you
asking. Okay, go.
well if you fail at parsing while you are interleaving reading and execution, if you fail there, that's essentially just a compilation error. There's no difference between that and a compilation error in a more normal language.
Yeah, but is there a
No,
concept of
but I say
syntax error?
yeah, yeah.
Is there the concept of a syntax error in that case?
No, but let me just step back a bit. What happens if I have A or B, and for let's say that both are valid parsers for the string that's coming in, and but if you parse A and later you fail, but
You already commit.
you
You
would
already committed to A at that point.
you already committed to A at that point.
Yes.
You don't go back to B,
But he could.
which
That's
would be
Yeah, but he
which
could.
would
That's
be
what
a
I'm
valid
saying.
passer in, for
Because
example.
his parser is already glued to the context of the evaluation. If he
Mhm.
wants, I don't know. Probably I don't know if he should because maybe this is going against Marinho's design idea. But
I wouldn't.
because the parser that has access to this sort of context, he's saying, "Oh, I parsed A before, but now I failed. Okay, let me try to backtrack and try to parse that before differently because I do know that I do know the
Mm.
future. That's the thing. The
If you
parser
if
can
you
backtrack
Yeah.
because of that.
I mean, if you do that, you're no longer a peg parser. At that point, you're basically turned into a context-free grammar. So, I'd rather avoid that because ambiguities are kind of
Yeah,
annoying
that's
to
the
deal with.
problem with that. Yes. Yeah.
Yeah.
Anyway, so
Right. Anyway.
let's assume that whatever Lisp is making, his parser he made in a parser combinator way that he has some certainty that is not ambiguous because as maybe Edu doesn't know, but Marinho, I think we already heard that when we did parser combinators for silverware, that we encountered this problem of ambiguity. Like at some point, changing the order of the choices made different the results in the parser. And that's when Nathan said, and that's why you use generators instead of this, because
Mhm.
we're gonna have to do a lot of debugging to discover why changing the orders of the choice changes the output. And
And
that
the generator probably forced you guys to rewrite the grammar in a way that's the balloon stuff again.
Yeah,
Oh
so Mario,
man,
let me. So in a Mac,
no.
apparently
Oh,
they have
my
gestures
nightmare.
active, man.
This.
Oh.
Look at this. Look at this.
So this is the balloon. So if you also make a heart, it's also gonna do something. If you make this, it's also gonna make something in
No,
his
this
screen.
is
Yeah.
it's
Oh, it's
something
confetti.
different.
That's nice.
No, this is something else.
Oh, that's fireworks. That's kind of nice, actually.
This is not nice because it triggers. when I'm speaking and I lose my mind when
Yeah,
and
so
I
it's
don't know what's
definitely
happening anymore.
his fault because he bought a new Mac, so it's your fault.
Uh,
Okay, anyway, let's go back. So, well, like I said, I didn't read this, so Edu read, but I don't know if you remember, Edu, what he's
No,
talking
it's
about?
he's talking about basic syntax differences between syntax and semantics in programming languages, and trying to explain that you have to do a synthetic analysis before going into execution or whatever happens later in the programming language pipeline.
Yeah, so he has an example of a
This is
language of
what's happening
Shiba
here.
Inu. Is
What?
this? Yeah, I'm not gonna enter
it,
that.
it's the dog meme, the Shiba Inu dog.
Oh,
Yeah,
okay,
yeah,
okay, okay. So
yeah.
okay, so
It's a
now I
meme.
understand. And then he says an adjective is this, a noun is either this, or that, and so on and so forth. And then he's using his parser community library to
Yeah,
implement that.
exactly. Just like an example to make normal people understand what's the synthetic
Yeah.
analysis meaning.
Okay, but this is
And
there's a new guy
at
here.
this what?
Yeah, there's a new guy here. So there's an MPC
Would
and then true
end.
str fold adjective noun and free. So let's try to understand what the heck is happening.
Yeah, you see adjective now are parsers that he
Yes,
built
yes,
with the
here.
parser combinator before. Uh,
As input we pass adjective our previously defined parser. This function also takes arguments str fold and free which say how to join or delete the results of these parsers.
Um,
Wow.
yeah, because he's doing malloc probably internally.
I see, because like, yeah, probably, but like,
Because
and
he's
is
trying to parse
actually,
the two things at the same time, right?
Yes.
And he
I
wants
think
to
and is
he
like,
wants to combine the final parsing, and
Go
he
yeah,
ahead.
needs to.
it seems like and is sequential combinations. Like, a
It is
phrase is
probably.
an adjective followed by a noun.
And I
Is
wonder
how I'm
if
reading
these
that.
things are also removing white spaces. Because I don't know, maybe he said that before.
No, but
That
he's going to implement Alexa if I'm not mistaken.
then it doesn't matter. Zero more classic,
Hmm.
which is the many. This function requires a special
Yeah,
variable str to say how the results are joined together. Uh, okay, so this means the language is infinite. Wait, what?
yeah, but
Oh, okay.
yeah, he's trying to, but because he's trying to present the parser combinational library before going to the real thing.
Yeah, more complicated languages. We sort of reads like a grammar.
Mhm.
Uh, yeah, it isn't an easy task. I agree with that. Uh, okay, natural grammars.
Yeah. On his defense, he
Woo!
go there's a appendix in this book that explains how to implement a parser without this external library.
Okay.
Since this is a Lisp, I would probably just write the parser out by hand because Lisp syntax is very simple.
Yeah, me too.
No, you wouldn't do that, did you? You wouldn't write in by
Nope.
hand. I know you. Uh, oh well, maybe. But Marinho, would you do that, like transforming everything with like the quoting and stuff like that?
It depends. Like, if I was like writing a more normal Lisp, I would probably just read the entire, like, dump the entire source code into a buffer, so it's all in memory at the same time instead of having to go character by character. Because that's actually easier to work with for backtracking purposes, right?
Mm-hmm.
Uh, and then um, and then I would just write it out in a recursive descent style, because that's actually, if you know how pegs work, they are basically a formalization of recursive descent parsers.
Okay, I'm not aware of that. Like I'm not very into
Yeah,
that. I need to learn that.
Yeah, like because a context-free grammar, it's a grammar, right? It
Yeah.
generates languages. There are algorithms that take a grammar which generates languages, and then you compute based on the grammar. You can recognize the language,
Mhm.
but a peg is different because the peg itself it's in the name. It's a parser expression. It's a recognizer. It's not a generator.
Mhm.
Mhm.
So because it's already a recognizer in the first place, there's a very straightforward mapping you can do between it and a just handwritten recursive descent parser, which
Okay. Okay. So if you have references on that, please send in the whatever channel so I can take a look later.
um, the best reference for this, I think, is actually the white paper on LPEG, which is the Lua implementation of PEG. It's a very good
Okay.
paper. I highly recommend it. I'll
Okay.
link it in the chat.
Okay. So there's something really fancy going on here though. So is creating
Oh,
parsers.
this
So he's creating a parser.
this is not pretty.
I said yeah. I said fancy, not pretty. We don't have to
Yeah, no,
worry
this is
about
not
discard
pretty.
inputs with functions.
Yeah,
Uh,
I don't like that.
Wait,
No, this is
rather
not
than
pretty
using C
because
functions that look less like a grammar, we can specify the whole thing in one long string.
yeah, you see the long string there?
Yeah.
It's processed somehow by this
Oh, so
MPC
this is
lang
basically now
thing,
the EB
the
and
grammar.
F stuff.
Yeah,
Okay, so
kind of.
okay, so I understand. I understand. Yeah, it looks like a lot. Really looks like it. So we have a phrase here, which
DNF
is
grammars.
this and stuff like
Yes.
that. Wow. Okay, I didn't know that. Without having an exact understanding of the syntax for that long string, it should be obvious how much clearer the grammar is. Yeah, this looks more like a grammar.
Yeah.
We
Okay,
if
but
we learn all of the special symbols mean we barely need to squint. Yeah, that's true. Another thing to notice that the process is now in two steps. First, you create the name several rules using MPC new.
do you understand this is kind of a help because the compiler knows or the language server knows anything about the string structure to help you write it or even format it.
Oh no, you need to know beforehand. You need to know that beforehand. That's true. Um, yeah. So and
Right.
another thing that I noticed, you need to do a mapping between an MPC parser T and the name that you're gonna use inside the string. So
Mhm.
there's a lot of heavy processing going on here.
Apparently, Nathan is in the audience.
Yeah, he is. Okay, first you create create and name several rules using MPC new, and then we define them using MPCA lang. The first argument are the option flags. For this, we're just using defaults. The second is a long multi-line string in C. This is the grammar specification, which consists of a number of rewrite rules. Each rule has a name of the rule, a column, and it's terminated by a semicolon. That makes sense. The special symbols used to define the rules on the right hand side works as follows.
Yeah, it's kind of a reject thing.
First is required, and yeah, space is basically and. The pipe is basically or. This is kind of really
Mhm.
similar to the grammar we did in Silverware, Nathan. Yeah, so let's go there just for the sake of context. So when we were writing our language, we actually did a very similar document to that. So if you go to grammar and you see it raw, you can see a very similar thing going on
Mhm.
to what is written there. So ideally, when we were about to write the parser combinator to represent this, we would write this first to try to check for ambiguities
Oh,
firsthand.
definitely.
But because we are stupid, we did a bunch of the language without doing this document, and then later on, I said to Nathan, okay, let's do the document first to try to have a grasp of what we need. And the thing started growing very, very rapidly when we did that. Like, what's the syntax for kinds and stuff like that.
Mhm. Please
Uh,
enlighten me here because you guys are more cultured than I am. Is there any kind of formal analysis tool that gets for the grammar specification,
Yeah,
something like this,
yeah,
and tells you that
ambiguous.
uh, it's ambiguous or not.
Yes. So, and I don't know any specific tooling, but what I can tell you is when we were doing the initial draft of the query language for Record Tower, so the query language that we're gonna use to interact with the database,
Mm-hmm.
Racket, the library that we were using actually told us like there are X amount
Mm,
of ambiguous statements in your definition of your parser. Uh,
interesting.
yes,
Because
maybe there's
then
better
you
tooling
can
to say
prove it's
where.
ambiguous.
Yes, maybe there are some better tooling that tells you where it is ambiguous because in Racket it was not telling me where it's just saying the amount of
Mm-hmm.
I think it's called conflicts, which means that it's ambiguous, but maybe there's better tooling out there, and I believe there is like Okamo's uh, yeah this
In principle, this is a decidable problem, right?
uh oh man, Nathan, are you there? Do you know the answer to that question?
You guys are the guys from computer science and everything. I'm just an
It didn't
engineer.
said which tokens were conflicting. Maybe there is an option to say which tokens, but it was not telling me in the vanilla when I was running. Anyway, Nathan is writing, but I believe this is a decidable problem. Yes, if using parser generator, this is an entire parser generators thing. Okay, this is parser generators, which is not parser combinators again. Uh, and here,
Actually, parser combinators implement uh, a specific kind of parsing strategy,
yeah,
right?
it's a parsing strategy, but you have like known problems such as the easiness of having ambiguity and the left recursion, right? The left side.
Mm-hmm.
Nathan knows a
Left
lot more than
recursion.
this than me.
Yeah, left recursion is something that's problematic, specifically, in particular for PEG-based parsers. There are implementations of PEG that do allow you to have left recursion, but naive ones don't. And the reason for that is if you translate it straightforwardly to a recursive descent parser, which you can do it with a PEG, and if you have left recursion, that means the first thing that the function does is call itself, which is
Yes,
obviously an infinite loop.
yes,
That's why it's not usually allowed.
yes. But look at this. Main here explains conflicts in terms of the grammar, not just in terms of the automaton. Are believed to be are believed to be understandable by mere humans. What a statement. We
What
use
kind of
this.
humor?
I think we use this when we were trying to make the database in OCaml first. And what's actually really cool about this one is that this is the first one that I know that I'm aware of that you can actually check the generated parser because OCaml's put the parser in a hidden folder inside your project, and then you can actually open and read the OCaml code that was generated automatically by the library, which is really cool. Anyway, okay, so Nathan is saying that it's I guess it's not undecidable. Yeah, so I think you can check this. You can check the ambiguity of your grammar, which is a problem. Which is again, it's very easy to add ambiguity when doing parser communities, unfortunately. Anyway, so this is very similar to this document here. I just wanted to show you another example. I don't know if the symbols are exactly the same, but it looks really similar. So this is the pipe is the or and the space is and stuff like that.
I think the
Uh,
main difference
Kind of
is
a
that
standard, right?
I think the main difference is that it's using semicolons to separate the clauses, like the rules.
oh yeah, it's using semicolons. We're just using new lines in our case here.
Yeah, but it's one long string. It would be kind of strange to use new lines, right?
Yes, it would be.
He needs a symbol for this.
Oh, and we also added the notion of functions. So I don't. This is not being shown here. So because it was getting very repetitive and very long, we decided to like make a piece that receives something and uses that something in this block. Such like this is basically now a function, right? It receives an A and uses the A in the body, and
A,
then you. And then you,
Function to generate grammar. A
yes,
grammar function.
yes, yes. And again,
Oh.
this is not formal. We're not PhDs and whatever. We just wanted some notation to explain our stuff, and without having to repeat ourselves, which made it a lot easier to describe the grammar. And of course, what we would like to do is to pick some piece of software, puts this grammar in, and ask if it's ambiguous or not. And then there's the other problem, which is how do you know that this grammar is being correctly mapped by the combinators? So in our case, we have two problems instead of one. Anyway, okay, so this is basically his description of this other way of doing the
Mhm.
parsing instead of doing parser combinators using this sort of how's it called?
This library.
Yeah, no,
The library.
yeah, grammar specification.
Mhm.
Um,
It's very similar to EBNF, right? Extended
yes, it's really
Backus
similar
Naur
to
form.
EBNF. Yes. The method we are going to this method of specifying grammar is what we are going to use in the following chapters. Okay, so he's not really doing parser combinators though.
No. He's just explaining the library here.
Okay.
Yeah, the thing about
He's
this
not doing
particular,
anything
the
yet.
thing about this grammar there, he mentions it in the text of the book, but that grammar is actually implemented using the parser combinators he showed earlier.
Oh, this one. So whatever
Yeah.
you do, this is deep like under the hood, is being written using the other ones.
No, like the implementation of the parsing that goes on is that you know obviously has to parse that big string to emit
Mm-hmm.
your grammar, right?
Mm-hmm.
That parsing is done using the
Oh,
parser combinators of the library itself.
okay. So it's kind of like self-hosted.
Yeah, kind of.
Okay. It might seem overwhelming at first. Grammars can be difficult to understand, but as you continue, become much more similar to with how to create and edit them. This chapter is about theory, so if you're going to try some of the bonus tasks, don't worry too much about correctness, thinking, the right mindset. You can create new notation. Okay, so then there's some code, and then some
Bonus.
exercises here, and then okay, so describe JSON in grammar. Very interesting.
JSON JSON is actually surprisingly simple.
Yes, no, JSON is very simple. So do you have parsing? Yes.
No, but parsing is for the next chapter, I believe.
Yeah, no, but you are already using the other way that he just
Yeah.
described. That's very cool.
Yeah.
That's very cool. Okay, so I think we are done for today. So what's the next chapter? Okay, so chapter 6 is about parsing.
He's going to build a very simple arithmetic expression evaluator. And
Okay,
then he expands from there.
Polish
parsing
notation.
using.
Yeah, Lisps are not really Polish notation because um, it's
Wait.
basically just normal functional notation, except instead of the open paren being on the right of the function name, it's on the left of the
I
function
don't
name.
even know what is Polish notation.
Polish notation
It's
is like,
prefix notation for arithmetics.
yeah, it's prefix notation
Oh,
for
so it's
arithmetic.
prefix. Okay.
And because it's for arithmetics, which, operators in arithmetic, they have well-known arities, they are simply arited.
Mm-hmm.
um, because of that, you actually don't need any parentheses to write
Mm-hmm.
expressions in that notation.
Oh.
Yeah, it's stack based.
It's kind of stack-based, except it's backwards.
Yeah, but
Oh,
no,
it is
Database,
it is
it's
backwards
stack
stack
based.
based. It
It
is
is a stack.
backwards. No, it is
yeah,
backwards stack
actually,
based.
yeah, stack-based would be reverse Polish notation, which puts the
It's
operator
Okay, no,
postfixed.
you're right. No, yeah, you were right. It's just
Edu, you are
prefix
talking
notation
with
for
a
the
with a
things.
fourth fanboy. So like
What does that mean? I don't know what's fourth.
fourth?
What
Okay,
fourth
you need
is.
more culture, man. You really need more culture. There. So
I
fourth
just
programming
know that's
language
a programming language, but I'm
is
not
a
aware
concatenative
of.
stack-oriented programming language.
I don't know what that
I
So
means.
think
that
there's some
means
example codes down there.
uh,
Yeah,
no, this one is not good
more.
though.
It's stack based. So
Yeah,
there's a
Yeah,
stack
so
and you
it is.
push and pop things from the stack.
Yeah, here,
and
here.
you operate on the stack. But what
Yes.
is a
Con-
concatenative means?
concatenative. Go, Mario,
Concatenative
go.
means that if you put normally when you put two expressions next to each other, that usually represents a function call, right? In a
Yeah.
Yeah.
concatenative language, putting two expressions next to each other actually means function composition. So in effect, you when you put one function after another, that actually means call the first function and then the next function.
Yeah.
Because
Look, here's an example. So you have y, which is the result of food applied with x, and instead of doing that, instead of picking the y
Oh, I
and putting to
see.
bar, you're basically composing them. But this comes naturally. This is a
Yeah, because if you have a stack, you just leave things on the stack, you operate
yeah. And
implicitly on
another
the
thing
stack.
to be aware is that I believe stack-oriented programming languages are the only ones that use postfix notation, which is very rare. We have Lisp with prefix.
Postfix
We have the other ones like Python,
everything.
Haskell, which is
Yeah,
infix,
everything
and then we
else.
have this, which is, as far as I'm aware, the only one that is actually like really representing postfixed notation.
ah,
Because you have to fill the stack before
Yes,
yes,
ask
yes.
yes,
calling a
Uh,
function, right?
yes, yes.
Yeah, but actually, fun fact, although the runtime is postfix, if you do any metaprogramming, it's actually prefix based because metaprogramming in
Mm,
for it's basically it splits the input stream into words by white space essentially.
mhm.
And then each word is either a function name, which is just compiled as a function call, or
Yeah,
it's a number literal, which is compiled as a number literal, or it could be um, a parsing word. And a parsing word basically it takes over the parser and it can arbitrarily parse text. But because the parsing word that takes over the parser has to be found first before it takes over the parser, it's effectively a form of prefix notation.
yeah,
But this only applies to code that runs in the reader, basically. If you're doing metaprogramming in Forth,
yeah,
the entry point is prefix based. Otherwise, normal code that runs that computes things at runtime is postfix
yeah,
consistently.
yeah. And if you want to check more about that, like aside from the Wikipedia page that I just showed you, you can actually check our code because now we have examples thanks to Marinho. There.
It's written in Objective C. Yeah,
Okay, so uh, this is a
that's
proposal of syntax of our assembly, which is stack based, right? So
Just a
I
side note here, because I'm studying Bitcoin, Bitcoin, the Bitcoin's protocol is based on a stack-based scripting language to describe transactions
do you
on the
know its name?
system, and it's called script. So
Okay,
ask
so
that's
for Bitcoin script. It
okay,
looks like an assembly language, but it's stack based. It's non-Turing
fourth
complete.
like.
it's
Yeah, now
Forth
I
like.
understand. It's the fourth like thing that people were talking about today, and apparently there is
No, yeah, looks assembly.
there,
Looks like assembly.
yeah,
There's
no,
nop.
it's
There's nop.
it
Oh man,
yeah,
you
yeah,
know what
yeah,
we could do,
it's
Marinho?
like
We could
assembly.
compare our instructions with theirs to see what other choices they made in the design.
Yeah, but
Yeah.
just remember that this is a non-Turing complete machine, which means there are no loops,
So there's no jumps.
essentially, no jumps, no loops, and there are some cryptographic primitives. You see there crypto stuff
Yeah, so these are
there, like
basically
Uh,
primitives for
check
just
hashing, yeah, like hashing, checking signatures and stuff like that.
oh, so
And and
that's
and they have this log time things. Oh, so nice, these log time things, because they are instructions that in which the result depends on the time
so
of the
it has
system.
side time semantics.
It has a notion of time semantics. It's based, and actually it's very interesting, but it might be
Yeah,
super
that
complicated
yeah,
to
this
write
sounds
it, because
really
it
different.
might time might refers to the block that's the last block in the blockchain. So I can say something like, do something in 10 blocks from now, in
Mm-hmm.
10 blocks, right? And you don't
Yes.
know
Yes.
when
Yes.
are
Yes.
these 10 blocks coming. And you can say things like, do this at this exactly time. And it uses Unix timing, this
Yes. 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 Yes.
number of seconds from 1917,
Yes. Yes. Yes.
this which will break in some time in the future, right? It will totally break. It's
Yeah,
some time.
it will. I think it's 2038, if I'm not mistaken. There
No,
were proposals,
yeah.
and also
Sorry.
this is a proposal that's actually implemented in many operating systems. I think Linux is one of them. To just, you know, switch from a 32-bit integer to a 64-bit integer for the
Oh yeah,
Unix time. And then we basically have until the heat death of the universe to figure out a better way of doing things, because that's when
yeah,
it's gonna.
Yeah. But
yeah.
look at
This is
this,
what
money.
this is probably what's going to happen.
They have extensions for the very like stack. How can I describe that? Like over, dup, and rotation. They have other
Uh,
functions to do that, like functions that operates in terms of pairs.
oh, it has pick and roll. That's uh, that's annoying, but oh
Like
well.
if you watch Zozin doing Porth after like the second session in his playlist, he's already talking over and
Yeah,
rot and dup and stuff like that.
I already hate it because it's not simply edited.
No, yeah, but you see, there is apparently a trend in this community to try to implement higher level languages that compile to this here.
Yeah, no, that makes
That's
sense. That makes sense.
oh,
Like
that
that's
makes
the
perfect
purpose of having what I'm understanding. It's a VM as well. It probably compiles to x86 or something. And how do you know it's not
I don't
simply
know.
arithmetic, Mari?
because it has pick and roll. Pick and roll, they take a number on the top of the stack, and then they
Oh, it
pick,
is written
copy,
here.
and
It is written
roll.
here. Okay.
Ooh, yeah. Which means that actually the arity of those two functions depends on a runtime value, which means it's not statically known, which
Yeah,
means
yeah,
it's
yeah,
not
yeah,
simply.
yeah. I understand. We already talked about that. I understand your concern. I do understand.
What does this thing do? It takes an n number
And
and
the
it
item
takes
n back
the
in the stack is copied to the top. So you basically
it's
pick.
copied.
Yeah. So you
It goes
basic.
into the stack, blah 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 blah,
Yeah,
and
yeah, yeah,
picks
yeah,
up,
yeah, yeah,
take
Yeah,
something
move
and
it.
copy to the.
Yeah,
yeah.
either move it or copy it to the top.
Yeah, one is moved and one is copied. The row does the move and the pick does the copy.
Row. Okay.
Yeah, we don't have this sort of stuff
Why
in our
would
in
you
our
have?
assembly, in our assembly thing.
Why would you need this?
Uh,
If you need to operate on a value that's very deep in the stack, you bring it to
yes,
the top.
yes, yes, yes. So this is
But I
basically a
don't,
shortcut of do like
but I don't like it because
if you have a very long stack, you would have to do a
Yeah.
bunch of like um, uh, y- uh, simpler
Ops
operations.
or
Yes, you would have to do a
stuff.
lot of manipulations on the stack in a sequential, like with a bunch of instructions. And instead of doing that, they just made pick and roll.
yeah, far spirits don't like those two words, pick and roll, because you are treating the stack as an array,
Yes,
Yeah.
which may not
yes.
actually be the case if your code is running in an actual stack-based machine that has.
Yeah, so that's the thing. Our stuff is based on a paper, which is a proposal of hardware based on in a stack-based architecture.
Mhm.
Which basically, like, long story short, I don't want to remove credit from it, but long story short, they pick their registers and organize and make an interface for them that behaves exactly as a stack. So they group them, they put them in a specific order, and then you can only interact with them using a stack-based mental model.
Mhm.
So theoretically speaking, you could actually like there are some optimizations to that you can need to do in the hardware and stuff like that. But like you can emulate this architecture in any x86 machine uh, if you could change the assembly that's running, right? Anyway, So yeah, very interesting to know. But anyway, we already are in the 1 hour mark, so I'm gonna finish the recording here.